So I'm going to be talking about average rate of change versus instantaneous rate of change versus the average value of a function. So the average rate of change is the slope of the secant line, which is f of x plus h minus f of x, all divided by h, which is equal to f of b minus f of a over b minus a. And as you can see in the graph, a comma f of a and b comma f of b, and the slope of the secant line is the blue dotted line. So we are going to plug in values for a and b. So if we plug in 1 for a and negative 3 for b, f of b is equal to 9 and f of a is equal to 1. So f of b minus f of a, 9 minus 1, over b, negative 3, minus 1 minus a, is equal to 8 over negative 4, which is equal to negative 2, which is the slope of the secant line. Now on to the instantaneous rate of change, which is the slope of the tangent line at any given point. And it is defined by the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. If we look at the graph below, the tangent line is the dotted blue line, and the slope of that tangent line will be the instantaneous rate of change at the value x equals a. So we are going to find the instantaneous rate of change of the function x squared at x equals 3. To do that, we are going to use the definition of this, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now I'm going to plug in 3 for that, and that will be 3 plus h. And since it's a squared, we're going to square it. Minus 3 squared all over h, and it's the limit as h approaches 0. And we are going to FOIL that, so we're going to get 3 squared is 9. We're going to get 6h, and we are going to get h squared, and we're going to have minus 9 all over h. And this 9 and this negative 9 are going to cancel, and this h is going to cancel, and one of these is going to be gone. And this is the limit as h approaches 0. And the limit as h approaches 0 of 6 plus h is equal to 6. So the instantaneous rate of change at x equals 3 for the function x squared is 6. So I'm going to plug in a and a plus h into the formula that we used before, and that formula was the limit as h approaches 0 of f of x plus h minus f of x all over h. So if I plug in a for that, it is going to be a plus h squared minus a squared over h, and the limit, can't forget that. And then we are going to FOIL, so it's going to be a squared plus 2ah plus h squared minus a squared over h. A squared and minus a squared cancel, so we are left with that. And now we can reduce because all the terms have h's. So that's going to cross out, and one of those is going to cross out. So that's going to equal 2a plus h. And the limit as h approaches 0 of that function is 2a. The average value of a function. It is defined by 1 over b minus a times the integral from a to b of f of x dx. So we are going to do an example of the average value. So we're going to use the function y equals x squared, and we are going to go from negative 1 to 2. So if we were going to plug that into the formula of 1 over b minus a, so 1 over 2 minus negative 1 times the integral from negative 1 to 2 of x squared dx, and that is going to be 1/3 third times the integral, and the integral of x squared is 1/3 x cubed from -1 to 2, and that second part is going to be equal to 2 cubed over 3 minus -1 cubed over 3, and that is equal to 9/3, or 3, and then we have to multiply that by 1/3, and it is 1. So the average value of the function of x squared from -1 to 2 is 1.